When people imagine the universe, they usually picture a place crowded with galaxies, stars, glowing nebulae, and brilliant explosions of light. Telescopes show breathtaking images where space seems filled with color and structure in every direction. But that picture is slightly misleading. On the largest scales, the universe is mostly empty. If someone could zoom out far enough to see the true structure of the cosmos, something remarkable would appear. Galaxies are not scattered randomly through space. Instead, they form enormous filaments and walls that stretch across hundreds of millions of light years. These structures connect into a gigantic network, often called the cosmic web. Between those threads of galaxies lie enormous regions where almost nothing exists. These regions are called cosmic voids, and they dominate the volume of the universe. One of the filaments of this web contains our own galaxy, the Milky Way. From inside it, the universe looks busy and bright. But step far enough away from the galactic highways, and space quickly becomes unimaginably empty. The journey toward the darkest places in existence begins by leaving the familiar neighborhood of stars. Leaving the realm of galaxies. At first, the universe still feels rich with light. A spacecraft traveling outward from the Milky Way would pass countless stars before escaping the galaxy's gravitational influence. Spiral arms filled with glowing clusters and nebulae would slowly fall behind. Soon, the traveler would encounter neighboring galaxies drifting through the local group. The large spiral galaxy, Andromeda Galaxy, would loom like a massive island of stars across intergalactic space. For millions of light years, the environment would still feel relatively active. Galaxies appear like distant cities of light floating in darkness. But eventually, those lights begin to thin. The cosmic web is not uniform. Filaments of galaxies act like enormous bridges stretching across space, while vast gaps exist between them. Crossing one of those gaps means entering a cosmic void, and that is where the real darkness begins. Entering a cosmic void. Cosmic voids are the largest empty regions known in the universe. Some stretch for hundreds of millions of light years across. Inside these regions, the density of galaxies drops dramatically. Instead of thousands of galaxies in a given volume of space, there may be only a handful. Sometimes there are none at all. One of the most famous examples is the Boötes void, an enormous spherical region roughly 330 million light-years wide. For comparison, the Milky Way galaxy is about 100,000 light-years across. The Boötes void could swallow millions of galaxies the size of ours and still have room to spare. Yet, it contains almost nothing. Entering a void would feel like drifting away from civilization into a cosmic wilderness where the nearest galaxies are unimaginably far away. And as the journey continues toward the center of the void, the universe begins to look very different. The sky inside the darkness. From Earth, the night sky contains thousands of visible stars and a faint glowing band formed by the dense population of our galaxy. Inside a cosmic void, that familiar sky would disappear. Without nearby galaxies or dense clusters of stars, the heavens would look shockingly empty. A few distant galaxies might appear as tiny dim smudges scattered across the darkness. They would be so far away that even powerful telescopes would struggle to resolve their shapes. Between them stretches pure blackness. No glowing nebulae, no star-rich galactic band. Just a handful of distant lights surrounded by enormous darkness. The silence of such a place is difficult to imagine. Light from neighboring galaxies would take hundreds of millions of years to arrive. The void is so empty that entire civilizations could exist there without ever discovering another galaxy nearby. For an observer floating near the center of the void, the universe would appear incredibly lonely. Why voids exist at all? The existence of these gigantic empty regions might seem strange at first, but they naturally emerge from the physics of the early universe. Shortly after the Big Bang, matter in the universe was distributed almost evenly, but not perfectly. Tiny fluctuations in density existed. Some regions contained slightly more matter than others. Over billions of years, gravity amplified those differences. Regions with slightly more matter pulled in additional material and gradually formed galaxies, clusters, and enormous filaments. Meanwhile, areas with slightly less matter slowly lost even more material as gravity pulled it away toward denser regions. These underdense regions expanded faster than the rest of the universe and gradually became the cosmic voids we observe today. In other words, voids are not empty by accident. They are the natural consequence of how gravity organizes matter on cosmic scales. Traveling to the center of nothing. Imagine continuing deeper into the center of a void. The nearest galaxy might now lie tens of millions of light years away. Even powerful telescopes would see very little structure in the sky. The cosmic microwave background radiation, the faint leftover glow from the early universe, would become the most uniform signal visible in every direction. This ancient light comes from a time about 380,000 years after the Big Bang, when the universe finally became transparent. Even in the emptiest regions of space, that background radiation still fills the cosmos. It would appear as a faint microwave glow surrounding the observer equally from all directions. Aside from that whisper of ancient light, the universe inside the void would feel incredibly dark. This may be the closest thing to true emptiness that nature allows. The darkest place that can exist. Absolute darkness is actually impossible in the universe. Even the emptiest void still contains a few atoms per cubic meter. Photons from distant galaxies and the cosmic microwave background continue traveling through every region of space. But cosmic voids come astonishingly close to perfect darkness. In the deepest regions of the largest voids, galaxies may be separated by distances of hundreds of millions of light years. Light from those galaxies is so faint that the sky would appear almost completely black to the human eye. The observer would be surrounded by darkness on a scale difficult to comprehend. It would be the quietest, most isolated environment imaginable, a place where the universe feels almost absent. The future of the voids. Cosmic voids are not static. As the universe continues expanding, these empty regions grow even larger. Dark energy accelerates the expansion of space, pushing galaxies farther apart over time. Filaments stretch and clusters slowly drift away from each other. This process makes voids expand faster than the rest of the universe. In the far future, galaxies outside our local group will eventually recede beyond the observable horizon. From our perspective, they will disappear completely. At that point, observers inside the Milky Way may find themselves effectively living inside a cosmic void. The universe will appear dark, empty, and silent, even though billions of galaxies still exist far beyond the visible horizon. A universe defined by emptiness. It may seem strange, but the universe is shaped as much by its emptiness as by its matter. Galaxies, stars, and planets occupy only a tiny fraction of cosmic space. The overwhelming majority of the universe is dark vacuum stretching across unimaginable distances. Cosmic voids are the clearest reminder of that fact. They reveal that the grand architecture of the universe is not a crowded city of galaxies, but a delicate network of luminous filaments suspended in vast oceans of darkness. The brightest structures in existence are connected by the deepest emptiness imaginable, and somewhere in those enormous voids lies the closest thing the universe has to absolute darkness.